Today we're starting Chapter 3, which is entitled Real Numbers and Radicals. So we're on page 1 of our Chapter 3 notes, and our first section we're looking at is 3.2, Roots and Radicals. Square root is one of two equal factors, because 5 squared equals 25 and negative 5 squared equals 25. 25 has two square roots. The principal square root of 25 is 5. The square root of 25 is equal to 5, and negative square root of 25 is equal to negative 5, meaning we take the square root of 25, which is 5, and then just bring over the negative. This is written plus or minus the square root of 25 equals plus or minus 5. It's important to note that the square root of negative 25 does not equal negative 5. Note that the negative is under the radical. The square root of a negative number is not a real number. The square root of 9x squared, each is a perfect square, so the square root of 9 is 3, and the square root of x squared is x, so the square root of 9x squared is 3x. The square root of 49x squared, y squared, z squared, each is a perfect square, so the square root is 7x, y, z. It's important to note that the square root of a binomial, the square root of x squared plus 25, does not equal x plus 5. You never take the square root of terms. If you don't recall your perfect squares, then maybe we should write them down, because you need to be familiar with perfect squares in order to take square roots easily. Your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. Again, you need to be familiar with perfect squares in order to take square roots easily. Next, cube root. Cube root is one of three equal factors. 2 to the third, that would be 2 times 2 times 2, is equal to 8. So the cube root of 8 is equal to 2. 10 to the third is equal to 1,000. So the cube root of 1,000 is 10. Important to note, since negative 4 cubed is equal to negative 64, then the cube root of negative 64 is equal to negative 4. So the cube root of a negative number is a real number. Let's also write down some perfect cubes. Perfect cubes. 1, 8, 27. 4 cubed is 64. 5 cubed is 125. Also, negative 1, negative 8, negative 27, negative 64, negative 125. Let's evaluate each here. We have plus or minus the square root of 36. Square root of 36 is 6. Copy over the plus or minus. Negative the square root of 225. The square root of 225 is 15. Bring over the negative. The cube root of 27. The cube root of 27 is 3. The square root of 100x squared. Both are perfect squares. The square root of 100 is 10, and the square root of x squared is x. So 10x. Number 5. The square root of 4x squared y to the 10th. Each is a perfect square. The square root of 4 is 2. The square root of x squared is x. And the square root of y to the 10th is you take the exponent 10 and divide it by the root you're finding, which was square root. Divide it by 2. So that would be y to the 5th. Cube root of negative 125 x to the third. Well, the cube root of negative 125 is negative 5, and the cube root of x to the third is x. the square root of 16x to the 16th over 25. Okay, well the square root of 16 is 4. X to the 16th, you take the exponent 16 and divide it by 2. 16 divided by 2 is 8. So that would be 4x to the 8th over the square root of 25 is 5. So that's 4x to the 8th over 5. And our last one on this page, the cube root of 8x to the 12th, cube root of 8 is 2, and the cube root of x to the 12th, you take the 12 and divide it by 3 and get 4. So that would be x to the 4th. So 2x to the 4th. Next, page 2. The nth root. One of n equal factors. 3 to the 5th equals 243. So the 5th root of 243 is equal to 3. This is read the nth root of k. K is the radicand, n is the index. If n is odd, the radicand can be positive or negative. The cube root of 125 is 5. The 5th root of negative 32 is negative 2. The 7th root of 1 is 1. The 9th root of negative 1 is negative 1. If n is even, the radicand must be positive for a real nth root. The square root of 81 is 9. The square root of 625 is 25. The 4th root of 625 is 5. And the 6th root of 1 is 1. Recall our rules for powers. A power to a power, remember you multiply the exponents. We have x to the 2nd raised to the 3rd. That is going to equal x to the 2 times 3 or 6. X to the 2nd raised to the 4th will equal x to the 2 times 4, which is 8, x to the 8th. So the square root of x to the 8th, take the exponent 8, divide it by 2. That's x to the 4th. The square root of x to the 6th, y to the 8th. Again, take each exponent, divide by 2. So that will give us x to the 3rd, y to the 4th. And the square root of 4x to the 5th, y to the 6th. The square root of 4 is 2. The square root of x to the 5th, you're going to take the exponent 5, divide it by 2. 2 goes into 5 twice, so that'll give us x squared, with 1 left over. So a square root of x remains underneath the radical. The square root of y to the 6th, take 6, divide it by 2, and that's 3. So that's y to the 3rd. So our end result here is 2x squared y to the 3rd times the square root of x. To take the square root of the even power of a variable, you divide the exponent by 2. If we were looking at cube root, we would divide by 3. If we were looking at 4th root, we would divide by 4. To take the nth root of the power of a variable, divide the exponent by n. For example, we have the 5th root of x to the 10th, y to the 5th. X to the 10th, we're going to take the exponent 10, divide by 5. That leaves us 2. So that's x squared. And the fifth root of y to the 15th, take 15 divided by 5 is 3, y to the third. So the fifth root of x to the 10th, y to the 5th is x squared y to the third. The fifth root of 32, x to the third, y to the 25th. Well, the fifth root of 32 is 2. The fifth root of x to the third, 3 divided by 5. 5 doesn't divide in evenly to 3, so that simply remains fifth root of x to the third. The fifth root of y to the 25th, take the exponent 25 and divide it by 5. 25 divided by 5 is 5, so that leaves us with a y to the 5th. So our answer here is 2y to the 5th times the fifth root of x to the third. Number 3, the cube root of x to the 12th, y to the 15th. 12 divided by 3 is 4, so that leaves us with x to the 4th. Y to the 15th, 15 divided by 3 is 5. So the cube root of x to the 12th, y to the 15th is x to the 4th, y to the 5th. Number 4, we're looking for the sixth root. Okay, so we're going to take each variable exponent and divide by 6. And leave the remainder underneath the radical. So the sixth root of x to the 10th, we take x to the 10th, take the 10, divide it by 6. 6 goes into 10 once. So I'm actually taking 10 and dividing by 6. 6 goes into 10 once. So x to the first comes out, and the sixth root of what's the remainder? 6 goes into 10 once with a remainder of 4. So x to the 4th remains. Sixth root of y to the 6th, 6 divided by 6 is 1. So y to the first comes out with no remainder. So that's xy, sixth root of x to the 4th. Number 5, the fourth root of x to the 10th, y to the 20th. Again, we're taking the variable exponent 10 and dividing it by 4. 4 goes into 10 twice with a remainder of 2. So that would be x squared with a remainder of 2. So an x squared stays underneath the radical. And y to the 20th, take 20, divide it by 4, divides in evenly 5 times. So y to the 5th comes out. So this is x squared y to the 5th, fourth root of x squared. And our last one, number 6, the fourth root of 16 x to the 3rd, y to the 14th. The fourth root of 16 is 2. The fourth root of x to the 3rd, well, 3 divided by 4 doesn't divide evenly, so that's simply going to remain x to the 3rd underneath the radical. And y to the 14th, 14 divided by 4. 4 goes into 14 3 times, a whole 3 times, so y to the 3rd power comes out with a remainder of 4 times 3 is 12, subtracted from 14 is 2. So y squared remains underneath the radical. So our result here is 2y to the 3rd, fourth root of x to the 3rd, y squared. And this completes our notes for today.